Hello, everyone. Welcome. My name is Ali Naqvi. I'm the product manager at Johnson Labs of the healthcare AI platform. I'll be talking about AI model governance and specifically how it relates to high compliance industries. At Johnson Labs, we deal with a lot of healthcare clients. And given the fact that I'm the product manager of our healthcare AI platform, I've had a lot of experience with dealing with model governance with these high compliant customers. So with high compliance industries, specifically in healthcare, there are certain privacy considerations, of course. There can be sensitive data that could be coming in, like personal health information, or identifying information like GPS coordinates or address data. Because of these sensitive informations, there are certain legal considerations as well. So GDPR and HIPAA that was enacted, which is the Health Insurance Portability and Accountability Act that was enacted in 1996. Because of these privacy and legal considerations, there are certain requirements that we have seen that are common to many of our healthcare clients. First one is that the data itself can never leave their system. Because of the fact that it's so sensitive in nature, any leakage can cause strict penalties for our clients. And because of that, many a times they request that the deployments of applications and systems be air-gapped. That means there's no internet access to the application. Only they are allowed to operate within the private cloud or private network. The third is that there is encryption at rest, meaning that if there's a virtual machine and it has a data volume with sensitive data on it, if by chance it got unmounted, we know that the data will be encrypted. And secondly, any interaction between applications and the data is also encrypted, and that's also a requirement. And finally, there needs to be an audit trail. So who did what and at what time, at all times. So so there are more requirements, of course, but these are the common ones that we see from our healthcare customers. The first three are primarily infrastructure requirements, but the last one is more of an application logic. So every application will have its own way of dealing with an audit trail. And really, I'll focus on this point a lot more during this talk. From the perspective of model governance, the basic things that we have to consider are the fact that there needs to be versioning of an AI model, both of the source code and of the data. And the reason is we need to be able to reproduce the same results, same artifacts every single time. And if we can't do that, then that's a big problem. That should be really the baseline that we should be starting at. The second thing is because of the fact that model development is an iterative process, we need to be able to document and track the experiments. We need to be able to say, okay, when is a model reaching its optimal accuracy and precision metrics? We need to be able to know exactly when to cut off a release based on some sort of a threshold. So we need to be tracking the experiments and documenting everything. Once we're ready to cut a release from our experiments, there comes the process of more on the DevOps side, which is the continuous integration and continuous deployment with CI/CD. You need that capability to be able to push models into different environments and be able to promote, demote certain versions of the model if there are any problems. Now, the talk is about high compliance industry, so there are certain other requirements that arise from these basics of model governance. Number one is identity management. We need to know exactly who is the person who committed so-and-so model, who is the person who was tracking this experiment, who is the person who promoted a model into staging, into production environment. We need to know the identity of that person. We need to know whether they were even authorized to do that. And we need to, so that's identity management. We need some approval workflows. So that's more of a process-oriented thing. We need to have stewards for promoting model into different environments. There are other aspects as well, which is data provenance, what data came and when, what was the prediction outcome from that data, and also configuration provenance. So if, let's say, we updated a configuration, let's say a model was updated and needed a new secret, when was that configuration updated? So there's a lot that can be discussed, but for this talk, because there's a lot involved, I will not be talking about everything. I'll just be focused on the identity management part of things. Before I dive into identity management, I will talk about the basics, which is versioning, experiment tracking, and CI and CD. So versioning, I think everyone on the call will agree we've all been here. We have final.py and new final.py and final the latest for sure.py. Thankfully, as since we are all familiar with Git, that removes the need for us to be able to do that. We can use Git for source code, but we also have to talk about datasets management. So we all know the reasons for versioning. I'll just briefly go over it. We need to have a way to find what the best model is and have to have a documented way of doing that. We need to have failure tolerance. If, let's say, things go back wrong in production because of promoting a new model, we need to be able to revert back quickly. If there's increased complexity and more dependencies, we need to say which Git commit is the new dependency coming from. And then we need to have some stepwise deployment of the models. So Git is really useful for that capability for versioning the source code. But now for versioning of data, there is also, in addition to that, it's called DVC. And DVC essentially has the same language as Git. So you add a file, you can push it to a cloud repository. Most of the time, DVC is backed by either a file-based system or a blob storage system. You can also have a HDFS backend, but it can operate essentially exactly like Git. And then you can fetch a specific branch, you can check it out, you can pull the changes from the cloud-based storage. If you don't prefer cloud-based storage because of air-gapped deployments or so on, you can deploy blob storage that is local. And one example is MinIO. So this is essentially what it looks like when two data scientists are working on the same source code. They're interacting with the same Git server, and they're interacting with some sort of a storage system that can allow pushing of data files. DVC saves the metadata file in the .state directory within the Git server, so you can pull in the data from the cloud storage. What it means for high compliant industries is that for high compliance environments where you have air gap deployments, you have on-premise Git forges or on-premise and on-premise storage of either local, based on local file system or blob storage system. Okay, so that's versioning. So let's go over experiment tracking a little bit. DVC has the capability of showing metrics, but it doesn't have a web UI, so it's not easy to compare the let's say multiple different runs that you did. So there's a tool that's available for that. It's called MLflow. It's by Databricks, and you can compare important metrics between different runs, and then be able to select the right experiment for for creating the model and registering the model and promoting it to say a staging environment. Lastly, there's CI/CD. This is where things get quite a bit hairy, because with continuous integration and continuous deployment, you have many different ways of doing it. So for model, to get a model into production, the first thing you need to do is create a model object. So there needs to be a pickle file or an mleap object that is a serialized object of different machine learning frameworks. Or you can package the model object as a PMML file, which is language agnostic, and PFA and ONNX are also language agnostic. Or you can package your model as a jar library using H2O and add it as a dependency at runtime. So there are many ways to do it. There's no standard. So you have to pick what is convenient for you. It's kind of the same thing in model serving framework. So getting from the model object to model serving, you have to build a Docker container. You can either have it embedded within the application. So one common way of doing it, you have a Flask app and then the model file embedded within it. The second one is to have a model as a service. This is quite popular because then you can expose the model as an endpoint, as an HTTP endpoint, and you can post data to that endpoint and get back a response of the prediction. This is quite popular because of the fact that you can, in an isolated way, scale up or scale down the model based on some configurations. So let's say if the model is operating at 75% CPU, you can set auto scaling parameters to add in additional Docker containers to be able to handle the load. The third way is to use model as data. So you have an application that subscribes to PubSub event. And when a new model is available, it can pull it in, load it into memory, and have the prediction endpoint be served that way. Now with model as a service, this is getting more and more popular, and I think it's going to be the standard way of doing this. So I will be focused on that. Now the key thing with model as a service is that you can use this as a blue-green type deployment or canary type deployment. So it can follow a software development lifecycle. You can update a small portion, redirect a small portion of the traffic to a new model, and then see how it responds in production. If it doesn't perform well, you can demote that model. Now, many of the cloud services like Azure, Google, and AWS, they have that capability to have model deployed as a service. And there are several open source options also available. So if you're building your own platform, you need to evaluate what is available in the open source. One project that's available is called Kubeflow. It's by Google, and the other one is MLflow model registry. Here's an example of the model registry. It's a picture. So MLflow is by Databricks, so it's a picture of the Databricks view. The open source version currently doesn't allow audit trail of this capability. It needs to be enhanced, and as of yet, I haven't seen any updates so far. But essentially, over time, you would be able to have this audit trail within it if, let's say, you plug in an identity system here. So you can request a transition into production, and you can see that somebody rejected this transition, and you can see the names of who did what for this registered model. Now, we're talking about versioning and experiment tracking and CI/CD. Yes, that's important, and I've talked about all of these tools that are available, but what does that have to do with audit trails and governing a model in a high compliance? What I really want to get across is that as data scientists, we use a lot of different tools for various different actions. So for versioning, we'll use Git. We'll use DVC for data versioning. Experiment tracking, we have a lot of options available. CI/CD, there's a ton of options and ton of tools that are available. However, what I've found is that majority of the time, they are disparate systems. So every single one of them will be separate, will have a separate user store. They will not have a cohesive identity management system. And that's what I want to talk about, focus on today. So having a consistent identity management system is absolutely essential to building consistent workflows. You can't have a username from in one application like Anakvi, or in one application and Ali in another application. It just makes creating that audit trail very, very difficult. And this identity management system needs to be the centerpiece of the platform. It needs to be resilient to failure. It needs to be distributed to be able to follow the strong compliance requirements in the healthcare and other high compliant industries. So basically what I'm saying is authenticate all things. And just like how when somebody crosses a border, there's passport control, you have one identity using that passport, it's authenticated, and then you're allowed to pass through. The same way, we need to have an identity management system that can verify the identity of a person across all applications. So how do identity management systems work? The ones that I will introduce to you, they use JWT tokens. Um, they're they are an open industry standard, and they can represent what is the claim between two different applications. So what comes in a JWT token? It's a JSON token. There's a header piece which tells you the type of the token and the algorithm used to encrypt it. And then there are these things called claims, um, where you have a subject, let's say in this example, Jimmy, and what is the role, what are the roles associated with Jimmy? You can have that in the claim. Now, this is a very simple claim. There can be multiple sub roles for every single type of an application. And this token, when it's issued by an identity server, it contains everything that an application would need to know to give them access and permissions within the application. Essentially, it is one token to rule them all. This is a picture of Golem. So at Johnstone Labs, what we do is we have a central identity management system within our AI platform. And this is a high-level view of the architecture of it. So we have multiple different applications. We have Data Flow Designer, which allows you to design pipelines. So you need to have certain permissions associated with being able to create pipelines. If somebody isn't allowed to see the secrets within a flow, they shouldn't be allowed to see secrets within a flow. If somebody is allowed to delete, have admin permissions, they should be able to delete certain flows, things of that nature. So we can have per application different type of roles that can be sent out with the token. So for example, we have the annotator, which is a feature extractor. And you can send in a lot of different documents. Let's say, so the annotator that we have, we can annotate images, audio, video, and text. So let's say we want to create a project, and within the project we want to annotate text. We can create a configuration and taxonomy for the annotating that text, but we want to make sure that nobody modifies that taxonomy. So only an admin of that specific project can modify that taxonomy and create tasks associated with it. So we can do that using the identity server. If let's say we have two projects, if there's a person, user A, being an admin of project A, doesn't mean that user A is also an admin of other projects. So things like that can be done with an identity server. So once you have the identity of a person, you can track user-specific changes from within the application. You can even have the capability of user-managed resources. So if same idea as the annotator. If let's say if we integrated MLflow in this environment, we would be able to say, okay, this person would have the ability to promote or approve promotion to a production. So there would be resources associated with that user and permissions associated with the resource server. So there are multiple open source options that are available for identity management. There's Keycloak. At Johnson Labs, we use Keycloak ourselves. There's also another one called ForgeRock and WSO Identity Server. So in conclusion, one of the main requirements of high compliance industries is that we need to have an audit trail. And from what I've seen in data science, there's so many different tools that are available, but they're not tied together. And to be able to create an audit trail, the very first thing we need to do is to allow is to have a consistent identity server that can manage the authentication and authorization for all of the tools, which would then allow you to create consistent audit trails using application logic.